So the last bit we want to look at in this probability is something called conditional probability. So conditional probability takes into account something that's already happened. So the conditional probability of A, given that B has already happened, the way we work it out is, the symbol for it, by the way, is A, so that's what we're finding the probability of. Then we just have a horizontal line, and then B is the condition that's happened. Okay, and so it's the probability of A intersection B, both A and B happening, divided by the probability of B happening. Okay. Another way we can say it over here is just say, well, it's the number of events in A intersection B over the number of events in B. Because both of these would be out of the same sample space. So you'd have a fraction on a fraction, so you don't actually need the bottom of the fractions. So you could simply just say, oh, well, the number of things in the sample space over the number of things in B. So now, if it turns out that the probability of A, given the condition of B, is the same as just working out probability of A alone, then it must mean that A and B are independent events. One did not influence the other. Okay? Or another way of saying that, the probability of the intersection is simply probability A times probability B. If that works out to be that, then we know they're independent events. So here we go, let's do an example. We've got a mixture of people in class that study different languages, French, Latin and Japanese. Oh, let's go back to year 7. That's what we did, wasn't it? French, language, Japanese. And so they've given us that information using a Venn diagram there. What's the probability that a student who studies Indonesian, oh, that's good, isn't it? Oh, I wonder which language Indonesian is. Because I now remember when I went and got this example, they had 3 languages and I went, oh no, let's change it to French, Latin and Japanese because that's the languages you do in year 7. And I forgot to change Indonesian to whatever one it was. We shall soon see what language that was. Ah, there you go. Indonesian is Japanese. Okay, so that question should read, what's the probability that a student who studies Japanese also studies French? So the thing we know, the information we know is they definitely study Japanese. And we want to know, well, if that's the case, what's the probability that they study French? So we can look at our Venn diagram and we can see that it's a 3 out of 10 though, because I'm not including the ones that are not in the Japanese. I'm only looking in the Japanese, because we know that's a fact. It's only the students who study Japanese, and of those, 3 also study French. So that's where we get our 3 from 10 from. It's like the other ones just don't exist. They're not part of what we're considering. All right, so let's see if this is a bit more successful, eh? With 2 boxes, each have got 4 stones in it. The only difference in these stones is the colour. So box 1 has 4 black stones, box 2 has 2 black stones and 2 white stones. We choose a box at random and 1 stone is drawn randomly from that box. What's, first of all, the probability? Simply that we draw out a black one. Well, okay, what could happen? I could get the first box and we know, well, they're all going to be black. Or I could get the second box and I know, well, it's all right. A half plus a half times 2 on 4. Here's my logic. This is where all the numbers come from. The first one is a half. I have a 50-50 chance of picking box 1. So, probability of a half that I pick box 1. But if I pick box 1, then there's a probability of 1 that the stone that I pull out is black. So I didn't bother writing the times 1 there. Or, and then probably when we say or, we add the probabilities, I could have picked box 2. Well, there's a half chance that I picked box 2 times, but in this case, there's a 2 in 4 chance that I pull out a black one. So that's where all those numbers are coming from. I'm saying, okay, well, box 1 had a half chance, 50-50 chance, but then it must be black, so times 1. Box 2 had a half chance, but there's only a 2 in 4 chance that that one's black. Add that all up. So overall, there's a 3 in 4 chance that I end up with a black stone. Could we have simply just added them all up? Let's think that. All up, I've got how many stones? 8 stones? How many black stones have I got all up? 6? So I could have just done that. Which box I picked really was irrelevant. I could have just said, oh, let's mix these 2 boxes together, have one box which has 6 black and 2 white. And that would have given the same answer. There's different ways of thinking about problems. All right. But what happens if we don't know? We don't know which box the stone has come from. Given that the stone drawn is black, so we know we pull out a black one, what's the probability that I pulled it out from box 1? So the known thing here is it's a black stone. We now want to know what's the probability it came from box 1. So probability, box 1, given that the stone was black. So probability of it being black and from box 1 over just the probability of it being black. Okay. If it's black and box 1, then we said, well, that had a probability of a half that I picked box 1 times 1 for it being black. And then on the bottom, we just worked out probability of just being black is 3/4. So we end up with a 2/3 chance of it coming from box 1. Okay, let's look at another one. Particular school, 55% male, 45% female. Now, of the male students, 13% say Monday is their favourite day, while 18% of the females say, no, we also agree that Monday is our favourite day, but more of them said that, 18%. Find the probability that a student chosen at random is a male whose favourite day is Monday. So we're saying, we know the probability of male is 0.55. Probability of them liking Monday, given that they're male, is 0.13. So they've told us that there. So we want to know probability of Monday male equals probability of Monday and male divided by probability male. I can rearrange this equation to find then that the probability that the student I picked was both Monday and a male. So rearranging all that, there we go. It's actually a very small probability of 0.0715. So I'm using the same formula, but I've just got to rearrange the formula to get what I'm looking for there. So that's the idea of conditional probability. Okay.